So, why is any of this even important? Video 5. Why does this matter? Let's check it out. This big long formula that when I was your age we had to memorize, you guys don't have to memorize. Negative b plus or minus the square root of b squared minus 4ac, that's an a, all of that over 2 times a. It's the quadratic formula. We use it to solve quadratic equations. So it's not a flower pot. Yeah, it's not one of these. I'm not going to make you memorize this big long formula because it's given to you on a test. However, we can use this information in here, b squared minus 4ac, we can use it to tell us stuff. And that, my young students, I do want you to flower pot. So, b squared minus 4ac is called the discriminant. We'll write that over here. Discriminant. We'll make it smaller. Whoop. Discriminant, flower pot at b squared minus 4ac. And what you need to flower pot is when this equals 3 different occasions, what it means. If you plug in numbers for a, b, and c, and you get a number that is greater than 0, meaning it's positive, that means that you're going to have 2 real solutions. If you have a number, if you plug in a, b, and c and it equals 0, meaning it's not positive or negative, it's 0, you're going to have 1 real solution. And finally, if your number is less than 0, meaning it's a negative number, you're going to have imaginary solutions. You'll see that as no real solutions. Let's make this bigger. Whoa, that's not what I wanted to do. How do I? That's what I wanted. No real solutions. So that you need to memorize. Positive number, if you plug in a, b, and c into this formula called the discriminant and you get a positive number, when you solve, you're going to have 2 real solutions. And if it equals 0, you're going to have 1 real solution. And if it's negative, you're going to have imaginary solutions, meaning there are no real solutions to the problem. And then another little aside note, is that in these 2 scenarios, if it's a perfect square, so if it's 1, 4, 9, 16, 25, all those, if it's a perfect square, that means you can factor. Factor. Yes! Factor. And we learned how to do that and we practiced it and it was great and it was awesome. So, this really becomes the next step after you first and always put into standard form. And if you remembered standard form, that is the ax squared plus bx plus c equals 0. Always needs to be in that form before you do anything else. Put in standard form, ax squared plus bx plus c equals 0. Then after that, if you remember the very tippy top of our little chart, you always need to find out is, do they have a greatest common factor? If they do, pull that factor out. And then, after you've done these 2 things, you are going to do the discriminant. That's the first step. And why is that the first step? Is it because that lets us know a very big clue onto how we want to attack a problem and what our answers should look like once we decide to execute that problem. Step 2 is to use the quadratic formula, if you need to. Step 2 is to solve. Step 2 is solve. And solve can be done a variety of ways. You could factor it, you could use the quadratic formula, you could complete the square. You remember that? I'm abbreviating, complete the square. We did videos on that. And so It's very quite simple. If you put it into this form, pull out a greatest common factor, you use the discriminant, and you get a positive perfect square, that means you're going to have two real solutions, and it can be factored. Go ahead and factor that bad boy, save yourself some time. If you get down to this, and it's a positive number like, I don't know, square root of 40, that's not a perfect square. So use the quadratic formula and find out what your two real answers are. Or complete the square and find out what your two real answers are. The cool thing is this formula will always get you there. Complete the square will always get you there. It's just a matter of what you prefer to do. So what we are going to do at this point in time is I'm just going to write a problem up, and I'm going to go through our whole progression. That way we can do this together. So I'm going to add a new page, and way up here, I'm going to give us a problem, and it says 2x squared plus 6x equals -4. And so I'm going to walk us through how to solve this problem. Well, we're going to first put it into standard form. To do that, I need to get this guy over there. So I just add 4 to each side, and when that happens, now I get 2x squared plus 6x plus 4 equals 0. ax squared plus bx plus c equals 0. Standard form, awesome. Let's move this over here. Now, I need to see, oh, do they all have something in common? Well, darn it, they sure do. They all can be divided by 2. If I do that and I pull that factor out, I'm left with this. How fantastic is that? Now, I can use my new a value, b value, and c value to go ahead and factor or plug into my discriminant, which is my step 1. b squared minus 4ac. So if it helps, a value, what's in front of this x squared? A 1. B value, what's in front of this x? A 3. My c value, a 2. So let's execute. 3 squared minus 4 times a times c. What does that equal? 9 minus 8. That equals 1. So let's go back to this other page here. It's positive. It's not 0 and it's not negative. It's positive. So I'm going to have two real answers. And is that a perfect square? I don't know. Do square root of 1 in your calculator real quick just to check. You should know, but square root of 1 is 1. It is a perfect square. 1 times 1 is 1. Square root of 1 is 1. So the fact that this is a perfect square, so positive means two real solutions, and perfect square means factor. It can be factored. So I'm just going to do that real quick. So we have up here x squared plus 3x plus 2. So I need to ask myself, well, what times what gives me x? Well, that's easy. It's x. And then I need to ask myself, well, what times what gives me 2 and adds to be 3? Well, that's going to be positive 2 and positive 1. And if we remembered, I factored out a 2 at the beginning. So now, if I set these equal to 0 and solve, 2 equals 0. Well, that makes absolutely 0 sense. So that isn't a solution. X plus 2 equals 0. Well, to solve for x, I would subtract 2 from each side. So x equals -2. All right, now I look at x plus 1 equals 0. To get x, I would subtract 1 from each side. So x equals -1. Dang, those are real numbers, and there's 2 of them, and I knew that was going to happen. And this factored really nice and pretty, and I knew that was going to happen because that was a perfect square. Sweet! But just to show you otherwise, let's say you ignore this fact and you want to solve by, I don't know, completing the square. So let's move to another page. I'm just going to take this step right here, because you still have to do the first two steps regardless. So now I have this. Now let's complete the square. If I divide each side by 2, divide that side by 2 and that side by 2, that helps me out because those 2's cancel out and 0 divided by 2 is 0. So I'm left with x squared plus 3x plus 2 equals 0. Now, to do completing the square, we have to take half of this value and square it. So 3 divided by 2 is 1.5. And 1.5 squared is not 2. So that poses a problem if we want to complete the square. So I want 1.5 times 1.5 is, I believe, 2.25. It is. It's 2.25. So I need this number to be 2.25. So what am I going to do? I'm going to get rid of this 2. I do that by subtracting 2 from each side. And now I have x squared plus 3x plus this blank, and that's going to equal negative 2. Well, I just said we want it to be half of this number squared. Half of that number is 1.5, and 1.5 squared is 2.25. Math people, what you do to one side, you have to do to the other. So I do that, and my new expression becomes x squared plus 3x plus 2.25 equals a 0.25, because negative 2 plus 2.25 is a 0.25. Now, why we do this, why we complete the square, is because now I know that this value right here has to be 1.5, x plus 1.5 squared. So that's why we complete the square. And if I do that, if I do x plus 1.5, if I do that 2 times, x times x is x squared. 1.5 times 1.5 is a 2.25. And 1.5x plus 1.5x is a 3x. So that equals that. There shouldn't be any arguing there. So if I go back into this expression, we know that equals a 0.25 from up here. Now we just solve this like we would a normal math problem. Take the square root of each side. So now we have x plus a 1.5 equals square root of 0.25. What times what gives me 0.25? Oh, well, that's 0.5. Now, oh, dang, I almost messed up. Remember, it's plus or minus 0.5. Anytime you take the square root, it's plus or minus. And so now, to solve for x, which is our overall goal, I subtract 1.5 from each side. And so x is going to equal negative 1.5 plus or minus 0.5. And if we check this out, negative 1.5 plus 0.5 is negative 1. And negative 1.5 minus 0.5 is negative 2. X equals 1, and x equals negative 1, and x equals negative 2. Oh, man, was that not the same answer we got here? Yes. Oh, but let's say completing the square, not your thing. There is, in fact, one more way we could do this. So we took this equation, we put it into standard form, we factored out the greatest common factor, we plugged it into the discriminant to find out that I have 2 real solutions in a perfect square, meaning I can factor it, but instead I am going to use the quadratic formula. This guy, which is given to you, you don't have to memorize it. So let's do a new slide, and let's take this answer right here and start with that. So again, we're going to divide each side by 2. And that gives me x squared plus 3x plus 2 equals 0. So now, to solve for x, I just need to first label my a, b, and c. So my a value is out here. It's 1, my b value is 3, and my c value is 2. Now I just plug it into the quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac, all of that over 2a. Now what's cool is if you've been following our progression the whole time, you have already figured out this middle part. You have. You should have done it right here when you were plugging into the discriminant to see what was going on, and you can see that it's 1. 3 squared minus 4 times 1 times 2 is 9 minus 8. 9 minus 8 is 1. So, let's plug things in. Opposite b plus or minus, oh, this is what x equals. Opposite b plus or minus the square root of 1. And where did I get that? It's because I've already done it right here. 3 squared minus 4 times a times c gave me 9 minus 8 gave me 1. So if you do this, you've already done part of the quadratic formula. All of that over 2 times a, which is 1, so I'll leave it as 2. And so the square root of 1 is 1. So x equals opposite b, which is negative 3, plus or minus 1 over 2. So now we have two math problems. We have this problem dealing with the plus and this problem dealing with the negative. So let's do x equals negative 3 plus 1 divided by 2, and x equals negative 3 minus 1 divided by 2. Check this out. Negative 3 plus 1 is negative 2, and negative 2 divided by negative 2 is negative 1. And negative 3 minus 1 is negative 4, and negative 4 divided by 2 is negative 2. Oh, man. What just happened? I took a problem, and I went through some steps, and then I made a decision to either factor, complete the square, or use the quadratic formula, and each time I got x equaling the exact same thing. Pick your poison, people. Whatever you like to do, use it. Goodbye.